Hello friends, so today I will be explaining the concept behind the Bahubali physics. So if you have seen the Bahubali movie, or if you have not even seen the Bahubali movie, then in the Bahubali 2 there is a scene where uh, the warriors are tied to a coconut tree and they are some people are pulling this coconut tree all the way down with ropes, and then some people are standing on these coconut trees, and let's say this is the fort where they want to attack. Then when they cut this rope, they go on the top of the fort and they start fighting with the enemy. So how is this possible? This was my question. um, so decided to do a brief physical analysis of this. So what would have happened is, see, first of all, they were all covered with the armors and they all had some protective gear with them as well as protective weapons with them. So we should not forget that. Point number one. So how is this strategy useful in a war tactics? So I will tell you what all worked in their favor in this case. So for example, if we take a projectile motion, so this was a projectile motion. So what is a projectile motion? If an object starts from here and then goes to here and then again goes down, that is called a projectile motion. Like if I am standing here, I throw a stone in the air towards someone, then it is a projectile motion. So what happens in the projectile motion on the stone, or on the humans in this case, the warriors in this case? There is only one external force, which is gravity, which is acting in the vertical direction. So what happens is, and there is no force in the horizontal direction, so the horizontal component of velocity v will remain constant. So whatever horizontal velocity these warriors started with, their velocity, horizontal velocity, will remain the same till the end of the projectile motion. However, their vertical velocity will keep on decreasing in the upward direction, like they were going upward fastly, and at the topmost point their vertical velocity becomes 0, and then the vertical velocity becomes downward. So the first thing is, when they came here, there, let's say we throw at an angle where they land just at the top of the fort, here, somewhere here. Then when they land here, there is vertical velocity is 0, but they have some horizontal component v. So when they land on the ground, there is no normal force from the ground. So that is one thing in favor. However, as they are moving in this direction, v, with velocity v, the ground is stationary, and here the force of friction comes into play. What is force of friction? So let's say I am here and I am trying to move like this. So then there is a force of friction acting between me and the paper, my finger and the paper. But let's say both are moving with the same velocity, then there is no friction. Why? Let's say this and this are moving in the same velocity. There is no friction. I am moving this and this with the same velocity. No friction between the pen and the paper. Why? Because friction opposes relative motion. Friction opposes relative motion if sorry, if there are two objects, both of them say I am moving with velocity v, the other one say I also want to move with velocity v. So the friction is okay, then you guys move together. I don't want to stop you from moving. I want to stop relative motion between you, because there are like deformities in the surface of this and surface of this, like they are not perfectly plane, right? So those surfaces like crash with each other, and that's the force of friction. So force of friction is happy when they are moving with the same velocity, but here it is not the case. The ground is stationary, but the warrior is moving with a v velocity in the front direction. Okay, now I will mention one more point. The force of friction is much lesser than the force of normal force of impulse, you can say. Impulse force is like when the collision happens. So if I throw someone from the top of a building and they hit down, then that is the impulsive force. That's why people die. Okay, so why people die? Because if I'm throwing some person from top of a building, something from a top of a building, then at till this point their velocity is like, let's say, 10 meters per second, and in the just next instant their velocity becomes 0, assuming that the person doesn't collide, doesn't like